Welcome back to the deep dive, everybody.
Okay.
Today we are going to be exploring something that sounds really complex, but it's actually pretty intuitive. We're talking Monte Carlo simulations.
Oh, yeah.
It's like, imagine like having this tool that lets you peek into like all these different possibilities.
Mm-hmm.
It helps you make like smarter decisions even when you're like facing a ton of uncertainty.
Right.
That's like the magic of Monte Carlo simulations.
Yeah, and these simulations, I mean, they're incredibly versatile. We're talking everything from, like, figuring out if you're going to make it to that party on time,
Oh, yeah.
all the way to, like, managing investment portfolios, to assessing risks,
Oh, wow.
even creating those stunning visuals that you see in movies and video games.
Oh, that's so cool. It's mind blowing, right? So to like guide us through this like fascinating world, we've got a couple of sources lined up.
Oh.
We're going to be checking out a couple of YouTube videos,
Okay.
one from Risk by Numbers and the other one from Marble Science. And then along with some text explanations just to like really like get into the nitty gritty.
Right.
So the Risk by Numbers video, like I think this is a great starting point.
Yeah?
They present this relatable scenario that shows how Monte Carlo simulations can be applied to everyday problems.
Absolutely.
Like those dilemmas that we all face.
Yeah.
Like they set up this classic work-life balance problem.
Okay.
You've got two reports that are due for your boss. Let's just call him Todd,
Okay.
by like the end of the workday. But you've also got this party that you absolutely cannot miss at 6 p.m.
Oh, no.
And of course, there's the catch. You don't know exactly how long each report's going to take to finish.
Yeah, that's a problem.
So the first report could take you anywhere from like 1 to 5 hours.
Okay.
And the second one, well, that one's even trickier. Could take you anywhere from like 2 to 6 hours.
Woof.
Talk about a time crunch.
Yeah.
So how do we figure out if you can like make it to that party, without facing like Todd's wrath the next day?
Right. That's the question.
There.
Well, that's where Monte Carlo simulations come in.
Okay.
We start by just acknowledging the uncertainty in each task.
Okay.
So in this case, each completion time within that given range is equally likely. It's what we call a uniform distribution.
Okay, so it's like each hour within those ranges has an equal chance of being the actual time it takes to complete the report.
Exactly. Now imagine a computer simulating this process thousands or even millions of times.
Whoa.
Each simulation randomly picks completion times from the ranges that we defined.
So the computer's like basically like running through all these like what if scenarios.
Yeah.
Just like playing out all the different ways that like this evening could unfold.
Exactly. And then by analyzing the results from all those simulations, we can actually estimate the probability of finishing both reports within that 9-hour deadline before the party starts.
Okay, so let's get to the big reveal. What are the chances that you're going to be partying tonight, or are you going to be stuck at your desk working?
Well, the simulation, as per the video, shows about a 12 to 13% chance that you won't make it to the party on time.
Oh, that's a little bit of a nail biter, isn't it? So would you risk it? 12 to 13% isn't huge, but it's definitely not insignificant either.
Yeah.
It really makes you think about like how much risk you're willing to tolerate.
For sure.
Now, this scenario is like super relatable.
Yeah.
But Monte Carlo simulations, they go way beyond just helping us decide if we can make it to a party.
Oh, yeah, for sure. And that brings us to our next example, which involves marbles, a table, and wait for it, estimating the value of pi.
Okay, I have to admit, that sounds kind of strange. How on earth do marbles and a table help us with something as complex as pi? This is where I'm really curious to see how Monte Carlo simulations can tackle a problem like this.
Yeah, it might sound counterintuitive, but the marble science video provides a pretty brilliant visual demonstration of how randomness can be used to unlock these complex mathematical concepts like calculating pi.
All right, walk me through this. How do marbles help us with that?
Okay, so picture this. You have a table with a square and a circular bowl on it.
Okay.
Above the table, you have a device that randomly drops marbles.
So far, so good. I can imagine the marbles bouncing around, landing in the bowls, maybe some missing altogether. What's the big insight here?
Well, the key lies in understanding probability. The probability of a marble landing in a particular bowl is directly proportional to the area of that bowl.
Okay.
So the bigger the bowl, the higher the chances of a marble landing in it.
Okay, that makes sense. But how does this connect to pi?
Well, the ratio of the areas of the two bowls is directly linked to pi.
Right.
The area of the square is simply its side length squared.
Right.
But the area of the circle is pi multiplied by its radius squared. So by counting the marbles in each bowl, after many drops, essentially using randomness to collect data, we can actually estimate the value of pi.
Wow, that's incredible. It's like harnessing chaos to arrive at a precise mathematical value. It really highlights how powerful this concept of using randomness for problem solving can be. And it reminds me of something you mentioned earlier, the law of large numbers.
Right.
The more marbles we drop, the closer our estimate of pi will get to the actual value.
Exactly. And that principle applies to all Monte Carlo simulations. The more simulations you run, the more reliable your results become.
Hmm.
This technique can be applied to problems with immense complexity, especially those where calculating every single possibility would just be impossible.
And speaking of complex problems, our sources hint at an unexpected connection between Monte Carlo simulations and movie magic.
Oh, yeah.
I'm completely drawing a blank here. How do these simulations end up on the big screen?
It all comes down to light. When light hits a surface, it can scatter in countless directions.
Yeah.
Accurately simulating the scattering is key to creating those photorealistic 3D graphics we see in films and video games.
I can imagine that trying to calculate every single path a ray of light could take would be a computational nightmare.
It would be impossible. It would be like trying to drink from a fire hose of information. That's where Monte Carlo simulations come in.
So instead of tracking every possible light path, we use Monte Carlo to randomly choose a bunch of paths to simulate, just like we use the marbles to sample where they landed.
Precisely. It's about making the problem manageable while still getting a reliable result. And just like with the marbles and pi, the more light paths we simulate, the more realistic and less noisy the final image becomes.
Wow.
It's another example of the law of large numbers at work.
So every time I watch a Pixar movie or play a video game with stunning graphics, I'm seeing the power of randomness in action. I have to admit, I never realized how much complex math and computational power goes into those visuals.
It's a hidden layer of complexity that often goes unnoticed, but it's a testament to the power of these simulations. And while these visual examples are certainly captivating, the applications of Monte Carlo simulations go far beyond entertainment.
Okay, I'm all ears. What other fascinating applications did our sources mention?
Well, they're used extensively in finance, for example. Portfolio managers use them to assess risk and predict potential investment returns under different market conditions.
So instead of just relying on gut feelings, they can run thousands of simulated scenarios to see how different factors might impact their investments.
Exactly. It helps them make more informed decisions, even when dealing with the inherent uncertainty of the market.
It's like having a glimpse into a range of possible financial futures. What other fields use these simulations?
Monte Carlo simulations are practically everywhere. They're used in medicine to model the spread of diseases and test the effectiveness of treatments. In engineering, they help design everything from bridges to airplanes, ensuring they can withstand various stresses and strains. And in astrophysics, they help us understand the evolution of galaxies and the formation of stars.
Wow, it seems like the possibilities are endless. They're this powerful tool that can be applied to such a diverse range of fields.
And the beauty of it is that while the applications are complex, the underlying concept is remarkably intuitive. We use randomness to understand and navigate a world full of uncertainty.
So after diving deep into Monte Carlo simulations, what's the key takeaway for our listeners? What should they walk away remembering about this fascinating technique?
Yeah, it's like we've uncovered this hidden language of the universe where randomness isn't just chaos. It's a tool for understanding.
It really is. And what's fascinating is that, despite its apparent complexity, the underlying concept of Monte Carlo simulations is so intuitive. You're essentially using randomness to explore this vast landscape of possibilities.
Yeah.
It helps you make more informed decisions when faced with uncertainty.
Now, our sources also touched on some important considerations when using Monte Carlo simulations.
Yeah.
They emphasized the need to accurately define the probability distributions of your inputs.
Right.
So in that scenario with your boss Todd,
Yeah.
in the reports,
Right.
we used a uniform distribution, assuming each completion time was equally likely.
Right.
But in a lot of real-world situations, certain outcomes might be more probable than others.
So if you're simulating stock prices, you might use a normal distribution, which accounts for that tendency of prices to cluster around an average value.
Exactly. Choosing the right distribution for your specific scenario is absolutely crucial for getting meaningful results from your simulations.
It's like using the wrong map for your journey. You might end up lost, even with the best navigation tools.
Totally.
Speaking of tools, our sources also mentioned the role of software in running Monte Carlo simulations.
Of course, we can't imagine doing millions of calculations by hand. Thankfully, there are tons of software tools available, from specialized simulation programs to more general-purpose tools like Excel or Python.
So there's something for everybody, from beginners to seasoned data scientists.
Right.
It sounds like the choice of tool really depends on the complexity of the problem you're trying to solve and your own level of comfort with the different software.
Exactly. But no matter what tool you use, the fundamental principles of Monte Carlo simulations remain the same. You define your inputs, specify their probability distributions, run a bunch of simulations, and then analyze the results to extract insights.
It's this elegant process of transforming randomness into like meaningful insights. It really does feel like having a superpower, doesn't it? The ability to peek into a range of possible futures and make decisions based on like the most likely outcomes.
It certainly does empower us to make more informed decisions in a world brimming with uncertainty. And that, I believe, is the most important takeaway for our listeners today.
It's a reminder that sometimes embracing randomness can lead to greater clarity and understanding. It's like those chance encounters or unexpected detours in life that often lead to the most incredible discoveries. So for all you deep divers out there, we encourage you to think about how Monte Carlo simulations might be used in your own lives, in your work, or even in your hobbies.
Yeah, share your ideas in the comments below. We'd love to hear your thoughts. And remember, there's always more to explore. If you enjoyed this deep dive, please hit that like button, subscribe to our channel, and let us know what other topics you'd like us to delve into. Your curiosity is what fuels our passion for exploration.
We're constantly on the lookout for fascinating new subjects to uncover, so don't be shy. Now, before we wrap up, we'd like to leave you with one final thought-provoking question. Imagine being able to simulate the possibilities of your own future decisions. What would you want to explore? It's a question worth pondering. And for our dedicated deep divers, be sure to stick around after the outro music for a special message just for you. Until next time, keep diving deeper.